Hey everyone, wanted to give some quick context to this video. I was making this orbiting clock. You can see the prototype in the front here, and I was running into all sorts of friction issues, and so finally wanted to bite the bullet, build a dynamometer, and really test out what some good practices are for this scale of work. Enjoy. Here's one of the first kind of official test setups, even though I'm not measuring anything yet. I have a stepper motor driving a 1/4 inch shaft. That 1/4 inch shaft is mounted in these rails on flange bearings, and then rigidly mounted is a MXL pulley pulling a toothed belt. On the other side is another 1/4 inch shaft, also mounted in flange pulleys on these rails, and then inside that is another pulley of the same amount of teeth, and it just has these two on as flanges to keep the belt from falling off. And what I'm trying to test here is the kind of drag and friction for different kind of bore types. And so this is just a loose fit 1/4 inch hole, maybe like 0.253, something like that, on in a piece of just cheap wood. And so what's interesting is you can see it's got enough drag to pull and rotate this shaft, even though it's a loose fit. And if I put a little friction on this shaft, you can see that about every rotation it grabs, and significantly. So that definitely shows me that this is not as great of a solution as I thought. It's got way more drag than I thought it would. I got some more measurements coming up. I think on the last test I was getting some kind of unfair kind of thrust friction between these because they weren't bound together, so they were turning at different rates. So what I did is I made these a solid unit. You can see it turns, turns relatively freely on this axle, so we're going to see if that makes a difference. So here we are again, and I have now taken this pulley and its flanges and made it one piece to just make sure there wasn't any friction happening there. And I'm still getting the same result. So I put a little bit of resistance on here, and I'm getting this kind of intermittent kind of pull. And this is a D shaft, so maybe there's something on the inside catching, but I also went through and kind of rebored this as one unit to try and make it nice and smooth. So glad I'm doing this testing because it is going to help. And I'm going to experiment with some other kind of bore types and see what we learn. So what's interesting now is I am running this pulley with a 1/4 inch wooden bore, and it has so much friction that it's actually causing the stepper motor to miss steps. And there's absolutely zero load on it other than the friction on the shaft. So you can see if we're worried about friction on this little thing over here, I can move it over and it's still missing steps, which is just outrageous. And so if we do let's say that's that little thing's 1.5 inches long, we're reading on the scale pulses of up to about 10 grams. And so we could do the math to figure out the kind of lost torque, but that is really bizarre. So I'm going to try and figure out what it is that's causing that much drag. So you can see I bored this out again a little bit larger just to ensure that it's a nice polished bore. I mean, really low friction when there's no kind of a radial load, but let's try this one more time before I move on. So I rebored this freewheeling pulley, and it seems a lot better. Now I'm still getting about roughly, I don't know, 7 grams on the scale, so maybe that's, I don't know, 10 inch grams or something like that of torque being lost. So still some loss, and it's still intermittent. I don't know if you can see that pulsing like that. And so there's something about it. One of my theories is that one of the pulleys is slightly eccentric, which as it turns, it basically is adjusting the belt tension. And if if we look at it run, we can also see a little bit of wobble, and that wobble could also change the tension slightly. So that's my working theory. But I do need some really good, I need no slop in the final system, and so I need to be able to carry a pretty high belt tension. And so if we look right now, this belt is pretty tight on both sides. So that would be a like functional system for me. I have no slop whatsoever. So that would work. Don't know why it's not working in mine though. All right, I thought I upgraded and it's worse. So what I did is I put in a brass shaft that's a nice loose fit on the 1/4 inch shaft. So there's like a brass piece of tubing similar to what people use for clocks. I got them from K&S Metals, and there is no conceivable thrust bearing surface, just the face of that brass, which is nothing. And in the same position each time, I'm still getting not only big spikes, but missing steps. So I don't know what the F is happening. One of my suspicions was that, oh, I am missing a bearing over there. Let me fix that. So it's running a little bit better now. What had happened is I'd lost the bearing in there. It had fallen out. But still, I'm turning nicely. Got all my bearings in. And I'm still getting this weird intermittent, I mean, we're spiking up to 15 grams sometimes, so that's, close to 20 inch grams of torque. And so that's happening somewhere. And because it's turning this shaft, it would lead me to believe that it has nothing to do with what's happening over there. So I don't know what's next. So I also moved over the shaft collar, and so this is free to move kind of to wherever it wants, and it doesn't like that. But it's free to slide around, and it's still dragging ass on that shaft. So I guess one of the other things it could be is the shaft itself. And it is a steel shaft, so there could be some elements of rust in it. Let me put that in the lathe and buff it up a little bit, and then see if that makes any difference. Be back. Here we are on the lathe. I'm going to use some steel wool and then some Scotch-Brite with a little bit of oil, see if I can make this thing nice and shiny. Don't have enough hands to film it. So I polished the shaft, and it is squeaky clean, super shiny, and I'm missing steps again. I'm getting surges up into the like 30 grams range, so which is like 45 gram inches. So good news is I think I figured out what was going on. My guess about it being eccentric, I think, is right. So if you watch me just put a fixed amount of tension on this belt, you can see it sag. I mean, let me do it with a bearing, so it's a little less. So if I take one of these bearings, you can see how much it drops. And the low part, when there's less tension, is when it operates best. So, as I would presume, the drag on the shaft is a function of tension, which is expected, so that's fine. But it's like really, really sensitive, and I don't know which one of my pulleys is eccentric, so I could try to figure that out also. I guess I could do it with a dial test indicator. Maybe I'll try that real quick. Now, I understand there are all sorts of things wrong with this setup right now, but just to get an idea of the swing, and I think that's in contact the whole time. So we're going from about, I don't know, 7 thousandths to about 30. So that, and I'm running it off the pulley, and so that pulley is pretty eccentric, and so that's definitely the problem on that side. Now, moving over to this side, I'll have to set it up. So this one is only eccentric by about 10 thousandths, which is more of what I would expect. So it goes from about 15, I think the base is moving, but to about 25. And so that eccentricity is definitely causing the problem. I'm not sure exactly why that is, because a lot of these are laser cut, so it should have reasonable precision, but it might be how I mounted it to a shaft collar, or I did re-drill that, and so maybe each time I drilled it I got off by a few thousandths, and then it added up. Disappointing, but I'm going to have to find a way to make that better or to deal with the friction. So next, bearings. So I drilled out a bigger bore. Now I'm going to pop in some flange bearings. Now I've got some cute little flange bearings in there, and we're going to check this out. So I've now installed bearings in this wheel, and something very interesting is happening. The first thing that's interesting is we are not actually spinning this shaft at all. This is completely loose, so there is almost zero drag on this. There's almost zero drag on the shaft, which is, kind of the point of this test. And so, that is already a tremendous difference, and those are just cheapy little eBay bearings. And so, I think that answers that question. Look at that. Totally free to move. But the other weird part is that we're still missing steps. So what the F? Let me hook things up a little better. So one thing that was happening was I had a clamp on here to hold this down, and it was bending it out a little bit, which was either doing some thrust friction here or putting the bearings out of alignment, I'm not sure which. But taking that off, the whole thing just runs, which is kind of amazing that there is absolutely zero drag on this shaft. And so we are running amazingly now, which is fantastic. We have the bearings. You can see there's almost no drag on that shaft. Sometimes just a teeny bit. Wonder if it'll even register on the scale. So we were getting like set between 7 and 30 depending on the setup last time, and we're getting nothing on the scale. So that's pretty fantastic. And you can see we still have this kind of intermittent belt tension issue, right? So we do have eccentric pulleys. Maybe that's just going to be the reality of the game without me driving myself crazy. But now I'm going to put a lot more tension on this belt, and I'm still not driving. I'm missing steps because there's something going on the drive side, but I'm still not adding enough drag to that back shaft, and so these bearings are going to be the thing to use. But I am curious what the hell's happening up here. Are these bearings out of alignment or something? The world may never know. One other discovery, now this is all mounting on bearings, is those little collars that I put there. I put them loosely against the bearings so the bearings wouldn't pop out. And there was slop back and forth. And even that little bit added a lot of drag to this system. So right now, we're not even spinning that shaft, no drag. And we're going to push them in a little bit. Oh, of course, now that people are watching. See, so there's a tiny, tiny bit of drag now. It's just moving that. There it goes. And that's just from adding in those little shaft collars. And so you can see there's actually quite a bit of slop in it. Like I can actually click it back and forth, yet it still creates that little bit of extra drag. So as I pack more and more things in, that may be a good reason for some thrust bearings. Hey everybody, hope you enjoyed the video. As you can see, I've got quite a bit of work to do putting bearings and both thrust and flange bearings into my project. Hopefully I'll get that started pretty soon, and we'll update you when I have stuff to show. In the meantime, check out my old videos, click subscribe, and thank you. Bye.